Hello again, Frank Fillmore and my colleague Kim May. Say hello, Kim.
Hello, this is Kim.
We are pleased to be able to present to you the IBM Db2 Analytics Accelerator. This is a product with which I think most of the attendees are familiar. So we're not going to do a lot of prep or background on the IDAA. We're actually going to dive right into where the IDAA is in 2019. I see a lot of familiar names on the webinar, and glad that you all are here. For the beginning, I'm going to keep everybody on mute, and then I'm going to open the lines up. We have a small enough group that we can be interactive, but by the same token, I'm very wary of background noise, the delivery man, the people typing on the keyboard, and the dog seeing a cat outside. So with all of that, I will keep you on mute just for a little bit so we can get started. But the first thing I'd like to do in terms of introduction is a poll that we have for all of you, and that is, and I'm going to put that up right now. Does your shop currently have an IDAA? I want to make sure that I am preaching to the choir before I assume that. So if you all could take a minute and let us know whether your shop is currently using an IBM Db2 Analytics Accelerator, that would be great. Also, while you're doing that, again, a brief introduction. I'm Frank Fillmore, principal in the Fillmore Group. We're an IBM Db2 repository and information management, data and analytics business partner for the last 30 years. I'm what is known as an IBM Gold consultant. My colleague, Kim May, is an IBM champion. And so we are bringing to you what we think is a really great product to help extend the life and the functionality on your Db2 for ZOS platform. We got our responses in, and yes, 100%, at least of the respondents of the people are currently using the IDAA. So without any further delay, our agenda today, the Fillmore Group, some introductions, which I've already done, a review of the capabilities included in recent IDAA version 7.1.x. IBM has moved to a continuous delivery model of upgrades. It used to be something happened in Db2 maybe every 3 years, and in between that there would be APARs and hypers and updates like that. But IBM wants to get functionality out into the field, and so basically now new functionality is appearing in this product every quarter, which is a pretty amazing rate if you're used to the past pace. So we're going to talk about the new capabilities that have been delivered just this year. We're going to talk about the return of an old friend, the high performance storage saver, the HPSS, the ability to archive data off of Db2 for ZOS and into the IDAA so you can keep many more months or years of data for analytics and customer support. New product feature called the integrated synchronization. This takes the place of the incremental update, the ICDC, the change data capture based replication from Db2 for ZOS. And ICDC is still there and it's still supported, but integrated synchronization offers a lot of benefits. So we want to talk to you about that. If you're currently using ICDC, you can still do that, but we want to give you the opportunity to understand what's coming and what's available and how that will improve the analytics that are available in the IDAA. We're going to talk about the Hybrid Transaction and Analytic Processing, HTAP. This was a term coined by Gartner that a single platform can provide not only transaction processing in OLTP, but also deep in-transaction analytics. So instead of copying data to an ODS or a data warehouse and finding 3 days from now that you executed a fraudulent transaction on Monday, you can now find out in transaction before you approve it with great savings to your business and to your customers. And then finally, some disaster recovery and high availability considerations. We're also going to do a deep dive into the ways that you can consume the IDAA. The IDAA now comes in 3 flavors or 3 form factors. One is the IBM Integrated Analytics System. This is the role that the Netezza appliance, also known as the Pure Data System for Analytics, used to play. That is being replaced one for one by the IIAS. So very similar hardware, storage, memory, processing capabilities all get wheeled into a spot on the floor in your data center, gets hooked up via networking to your ZOS system, Z system, and these are coupled together as a heterogeneous scale out of analytic capability. But there are two other ways. If you're not familiar with them, we're going to cover them in detail a little bit later. One is the Accelerator on System Z Docker container that runs on IFLs. This is wholly contained within your System Z mainframe, your Z13 or Z14. And then another flavor, the Docker container actually run on a different hardware platform, the Linux One box. We'll talk about migration considerations and then the buyer's guide, which is a Fillmore Group exclusive, which my colleague Kim put together to help you make a choice as to which form factor you may want to consider in implementing the IDAA with. I did an introduction to the Fillmore Group before. The services that we provide are Db2 for ZOS, version-to-version migrations, support of the IDAA, of course, as well as IBM and other vendor tools, and then Db2 Connect, replication and federation off of that platform. So a really quick one-page review of the IDAA. First of all, what it is a hybrid computing platform that couples with your existing System Z. So it supports transaction processing and analytic workloads concurrently, efficiently, and cost effectively. It gives you the capability to support mixed workloads. People who've heard me tell this story before know that IBM for decades told customers that you couldn't mix OLTP and analytic workloads on the same box. And IBM is saying, no, wait a minute, now you can, and here's how. Superior availability, reliability, and security, especially when compared to environments where data is taken off of the IBM mainframe and placed onto other platforms, whether an ODS or a data lake or some other analytic platform for the ability to do deep dive data science and other types of analytics on the data that you have. You come up with a series of platforms that may or may match together in terms of their security. You may have questions of data provenance, whereas with this heterogeneous scale out of the IDAA coupled with System Z, using all of the same facilities on System Z that you know and love today in terms of backup and recovery and high availability and DR, gives you a much better, much more cohesive platform.
Hey, Frank.
Yeah, Kim.
I'm sorry to interrupt, but we are still on the title page. We're not viewing your presentation.
I have closed. I'm not sure why. Let me see if I can fix that. Thank you for telling me, and I apologize. I've been paging forward. I closed the poll. Usually the poll is what does me in because I leave the poll open.
Right.
Let me try this. What do you see now, Kim? Do you see the
I see the title page that says IBM Db2 Analytics Accelerator IDAA Afternoon Show, the first page, not your presentation.
You're not seeing the presentation at all? Okay.
Correct.
How about now?
There you go. That's it.
Excellent.
Thank you.
Okay. Thank you.
Perfect.
Okay, so here's the slide that I was on. And again, I apologize for that, which is why I have Kim here to keep me honest. I also have some questions. So maybe there are going to be a lot of questions about why we're not seeing the slides, which I can dismiss pretty quickly. But also, if there are some other questions, now's a good time to take a breath. Yep, got one from Al. Thank you. Any other questions? Looks like we're good. Okay, I'm going to keep rolling. So the personalities that the IDAA can take are the access path with hardware assist early filtering, meaning that the accelerator acts as an extension to the Db2 for ZOS optimizer. The accelerator can be a full width index, meaning that the entire row can be searched on. All of the columns, if you have a 50 column table, all of the columns in the table are accessible and searchable, so that it is as if you had an index on the entire row. It can be considered a specialty engine, like the zips or the zaps that you have today, or the IFLs. Specialty engine, which has its own memory and its own processing capability, as well as its own storage in the case of the IIAS appliance. So all of that capability is available within the IDAA. It's an archive, as I mentioned before. It can be a table space. I can actually store what are called accelerator-only tables within the accelerator, not in Db2 for ZOS at all. I can perform ETL and ELT data manipulation in database in the accelerator, so I can transform the data from the OLTP format in which it's stored in Db2 for ZOS and move that over to the analytics platform and put it into, let's say, a star schema or some other form. I can also do fast federated joins across heterogeneous sources, so I can actually get access to data that's not currently available on the IDAA. And a way of looking at this is in terms of hybrid cloud. So one of the key design points with the IDAA is that everything that we have on the left in the blue and the blue background, applications, DBA tools, and ZOS consoles, is that this is the Db2 for ZOS that we have known and used for the last 30 plus years. On the right, that came in on the fly up, is the appliance form factor of the IDAA, the ability to have a separate box with its own storage and processing capability and memory to provide heterogeneous data analytics. The key design point is that everything that you're doing today in Db2 for ZOS still becomes the means by which you manipulate your IDAA. That is, you use the same system security. You use Db2 for ZOS for insert updates and deletes, for logging, for single record lookups where transaction ID equals 1, 2, 3, 4, 5. You do your backup and recovery. Db2 for ZOS remains the system of record. The management and the monitoring is used via Db2 traces and SMF records. There is no current external communication to the accelerator beyond Db2 for ZOS. And that's all by choice. So the value prop is a single platform image, single way to get at this data, a single API. You're still using Db2 for ZOS, SQL, commands, utilities. You reduce your ZOS CPU utilization. So we've seen customers who have implemented the IDAA and done that specifically to buy headroom by offloading workload from Z onto the IDAA platform, to reduce analytics latency. That is the example I gave before. I want to be able to do analytics in transaction. I don't want to wait till it gets moved to another platform a couple of days from now. It reduces complexity and it reduces the integration costs. So before I get to the what's new, I would like to open it up for questions. So I'm going to open all of the microphones for the background, and we'll see how well isolated you all are. If you have a question, please go ahead and speak up about anything that I have talked about so far, sort of IDAA 101.
Frank, I think the other question
self-muted until you actually come. You have to unmute yourself. I have opened the lines up so that it's available for you to take the mute off. Go ahead, Kim. I'm sorry.
Yeah, and I think the other question along the same line is sort of, is any of this new to anyone? I think this is all pretty much potatoes of the IDAA, but if there's anything anybody's seeing for the first time, it would be interesting to know.
Okay. Any questions so far? I'm hearing some background noise, but I'm not seeing or hearing any actual questions.
Yeah, somebody's in a room somewhere, it sounds like, yeah.
Yeah. Okay, if there are no questions so far, I will keep rolling, but I wanted to give you the chance to ask questions about anything that may be new you're hearing for the first time, as Kim said. Okay, I'm going to put everybody back on mute. Okay. And we have some more polls, so we'll make this as interactive as possible, and then we'll open it up at the end. So what's new in IDAA version 7? I called it a brain transplant. If you're familiar with version 5, if you're at that level, the version 5 database, the data store that was included in the Netezza or the PDA product, the appliance, was Postgres. The IDAA version 7 uses what IBM calls the Common SQL Engine, which is another way of saying DB2 for LUW. Also used in other IBM products, Db2 Warehouse and Db2 with Blue Acceleration. So what does that mean? What do we get from that? One is you get a columnar database. So instead of storing my data in rows, where I may, in my OLTP world, have 50 columns in a row of data, and I'm only interested in 5 of those columns for an analytics query, I don't have to move hundreds of thousands of pages of data into memory and be able to parse out those 5 columns. I can actually get access just to the columnar data that I need. So reduce a lot of I/O, by 80 or 90%, and increase the data density in the memory and increase the CPU efficiency. The next is what we call data skipping. Data skipping takes advantage of a feature that was found in the PDA Netezza, which is known as zone maps. Basically, it tells the database, self-maintained without any work on your part, the lowest and the highest, the minimum and the maximum value for any particular column that is found within an extent of the way that the data is stored on disk. So let's say I stored data that had a state column, and the states range from Florida to Georgia on a particular extent, but I was interested in Hawaii. Well, I wouldn't have to read that extent because Hawaii is not found between Florida and Georgia. I would know that that range of data didn't contain anything of interest, so I would just ignore it. And then finally, caching as much data as possible. IBM is very clear that the IDA is not an in-memory database, but the idea to exploit memory, large quantities of memory, and be able to take advantage of that is going to give you a lot better utilization of that resource and enable you to get analytic queries back in a fraction of the time that you would using traditional Db2 for ZOS. So the other thing that's new that I call the heart transplant is the move away from field programmable gate arrays, FPGAs, and commodity disks, what used to drive the IDAA in the Netezza and the PDA, Pure Data System for Analytics world. This move is now to power chips, IBM's power system chips, and solid state disks. So the 2 greatest complaints that I ever heard about in Netezza were disk failures and the incremental update. And IBM has basically done away with both of them now. So it used to be that the query got pushed down to the field programmable gate array. Now the query is applied against the columnar database using the blue acceleration with the memory utilization that we just talked about, as well as data skipping. So a different way to go after the data, but providing 9 out of 10 cases equivalent or better performance. There is an eye chart here. I'm not going to spend a lot of time on this. There are a series of benefits by making the databases basically the same. So there were a lot of problems with date formats in the TISA and in Postgres that go away now by using Db2 for LUW, because its date and date timestamp formats are identical in both platforms. Native support for bit data for all types of encoding. Better consistency in terms of SQL, and actually not only is the SQL more compatible, but the SQL supports a lot more functions natively that are available in Db2 for LUW that weren't available in the Postgres. The support of EBCDIC tables and the improved accuracy, as I mentioned before, for the timestamp, current date, and current time special registers. And the ability to perform a smart load using the sysproc XL load tables, the same one that's driven by the Data Studio GUI that you use to interact with the IDAA. So the compatibility is better, the consistency is better, the ability to move data between the platforms from Db2 for ZOS to the IDAA is better. So I wanted to talk a little bit about distribution and clustering. The other thing that IDAA incorporates is what has historically been known as the data partitioning feature, or DPF. This was IBM's MPP, massively parallel processing, shared nothing database approach that was in what was known as InfoSphere Warehouse. The DPF allowed a portion of the database to be stored on different nodes, typically different standalone servers, and be able to divide up the processing of a query so that you could have, if you had 3 servers, you had a third of the database on each of the servers using a hash key distribution. It allowed a query to be run against on those 3 servers simultaneously and be able to pull all that data back to a coordinator node and present the answer set. The more nodes you have, the faster it runs. So the distribution and clustering within the accelerator now relies, especially the distribution, on the DPF feature. It's not called that anymore, but for those of you who are familiar with IBM's Db2 for LUW, that's essentially what it is. The organizing key is what allows you to exploit the data skipping or the zone maps, so that I can say I want state to be an organizing key, and that way keep the range of different possible states on an extent limited. The minimum and maximum value will be very narrow, which means that if I do a lot of querying by state or by product code or by line of business or by organizational division, I can segregate that data and cluster that data so that it is a lot more bounded, and that my queries will run faster because I won't have to do as much I/O. So I mentioned the distribution keys. The distribution key works the same way in DPF that it did before, in that if I have tables that are joined together, commonly, I have a purchase order table and a purchase order line item table. They're always joined together by purchase order number, and they're both being stored in the accelerator. Then I want to have the distribution key for those 2 tables to be the same. In this case, purchase order number. If I do, you can see that this is the way I create the table orders and the table customers in this example. I want to make sure that I use the identical distribution keys so that the order tables that are at the top of the screen are going to be matched against the customer tables. I do my join processing in each of the partitions within the accelerator, and then that joined data is then provisioned into a single result set. If I don't use identical distribution keys, I get something like this. That is that the distribution key is on customer number for the customer table. It's the order number on the orders table, which means I have to do a lot of what are called broadcasts between the nodes. I have to move the data back and forth between the nodes in the database server, which means that I'll lose a lot of the efficiency of having the data partitioning feature. Now, you may have a table which is joined sometimes by one key and joined other times by another, and you can only have a distribution key on one set of columns. So that may be a choice that you need to make, or you may need to make a shadow table or a copy of that table, which exists in two different forms. Remember, this is all read-only data on the IDAA. The organizing keys, I mentioned the minimum and maximum instead of the full spectrum of values, so I can narrow that down. The organizing key data is ordered for specified columns like state code or product line or division, and then a synopsis table is created and maintained automatically for column organized tables and doesn't require any configuration or maintenance. So you don't have to do reorgs or anything like that. Basically a way of IO avoidance. Okay, so I'm going to take another pause here. I want to, what I'm going to do this time, I'm going to ask if anybody has a question, if you click on the raised hand, so I can just unmute that person, and that way you can also, if you have a question, pop something into the chat. We have a chat mechanism, but I want to make this as interactive as possible, and I want to make sure that I'm not going too fast, that you may have a question that we don't get to. So I'm going to just take a breath and a sip of water. Okay, we'll keep rolling. Kim, is there anything that you want to add or contribute at this point before I move into the enhancements and the version 7.1.x code releases?
No, I think you're doing very well. Keep rolling.
Okay, I will do that because we have lots more to get to. So the enhancement in 7.1.4, these are the deliveries that were in calendar year 2019, the hybrid transaction and analytic processing. And I'm going to go over that in more detail in a little bit, but that was a preview to say this is what is possible. The enhancements in 7.1.5 are the support for multi-row inserts for accelerator-only tables to speed the load of those tables that are used for reformatting or refactoring that data into, let's say, a star schema. There is coexistence for version 5 and version 7, and that is especially important for customers who are going to migrate in-place version 5 IDAs to the version 7 model and be able to do that over a period of time rather than as a big bang. You can actually specify a default accelerator for query routing to support these types of migration scenarios. And I have an example of the way that HTAP works. So one of the problems with the IDA as it was first constituted was that I would make a change into a table that was running on Db2 for ZOS, insert, update, or delete. We would use incremental update, the infosphere change data capture replication, to move the data across from one platform to the other, to the IDAA. Netezza, based on the way that it worked, was not very efficient in terms of consuming inserts, updates, and deletes. So the way that they got around this was that they created a series of mini batches, which meant that changes would accumulate for a minute or more on the IDAA, and then they would all be consumed as a batch. Well, the problem with that was if I opened an account in a financial services company and then I made a trade to buy some stock or sell some stock, and then I wanted to immediately run an analytics query on my holdings, I may miss the data that was just added in Db2 for ZOS because it had not yet made it over to the IDAA. And for a lot of customers that I talked about IDAA, they said it's a showstopper. If we're going to run analytics queries, it always has to be on the most current data. So IBM is doing a couple of things to get around this. Number one, Db2 for LUW, rather than the Postgres on the Netezza, is much better at insert, update, and delete DML processing. So you don't have to worry about the delay as much. You can do this near real time as you could today with Db2 for LUW. So that's advantage number one. Advantage number two is the integrated synchronization, which we're going to talk about a little bit later, to replace the ICDC, which is a much more efficient means of moving data over to the IDAA. The third is the HTAP processing, and that's what we're looking at right now. So the way that this works is, from a conceptual standpoint, I can issue a request, a data-intensive complex read. I want to do some type of in-transaction analytics to say, is this transaction that I'm processing right now fraudulent, based on a variety of different machine learnings, data science, artificial intelligence capabilities. So the first question that HTAP asks is the most recently committed data needed? Do I need the data up to the time that the transaction started? If the answer is no, go ahead and execute the query. If I'm only looking at historical data to make this decision, I'm not worried about it. Let's say that the answer is yes, however. I'm in the middle of the screen and I'm looking at most recent committed data needed, yes. So the capability exists today for ICDC to say, if the most recently committed data already applied, that is, the transactions that were completed at the time that my query started, that my unit of work started, if they've already been applied against the IDAA, they're there, go ahead and execute the query. If the answer is no, that the data has not been committed yet, that I need for this query, and I know this by table, I know which tables are involved in the query, go ahead and initiate the apply. Go ahead and take the data and make sure it gets updated. I wait for a certain amount of time, which is configurable by you, and then go back up and say, okay, after my wait period of 2 seconds or 5 seconds or whatever I say, is the committed data in the IDAA now? If it is, execute the query. And I can go through that cycle as many times as I want. Again, configurable, and then I can say, I can time out at a certain point and say, okay, I can't wait this long. Don't run the query. But the idea is I can ensure, using the HTAP, that I am always running my analytics queries against the committed data as it existed in Db2 for ZOS when my query started. I can guarantee that if it's needed for those analytics, which is a huge step forward. So now I can make sure that my data is always consistent. And if I open the transaction and I want to look at the data on a trade that I just made, I'll always see it. So in version 7.1.6, the encryption of data in motion, so all of the network traffic is encrypted. Accelerator on IIAS now has a call home feature for any sort of failure. This can be automatically instituted. So PMRs, now called cases, formerly called service requests, all the same thing, are opened automatically for severe hardware and software problems on the IIAS. Remember, the IIAS is using powered chips and solid state disks, so it's going to be a lot less likely that something like this is going to happen. But if it does, the IIAS can automatically notify IBM that there is a problem. So in 7.1.7, in April, the high performance storage saver returned. We're going to go over that a little bit more, but I know some of you out there are using it now. So the fact that this is available in IDAA version 7 is very important. The ability to store months or years of historical data in the IDAA, which does not also exist in Db2 for ZOS. So you get deep savings in your storage on your mainframe, your spinning disk DASG that runs on ZOS. compression for table reloads, reloads of replicated tables, support for more analytic pass-through functions, and support for very small deployments on IBM Z, and we'll talk about that in a second. So I'm just teasing here. And finally, this brings us more or less up to date. The June 2019 drop, I don't think that there have been any more since then, but high performance storage saver is GA, improved compression for all use cases in terms of the initial load, reload, and replication in terms of building the compression dictionary. The early support program for the integrated synchronization, we'll talk about that in a second, and several stability and user experience improvements. So query performance in terms of column group statistics, updating and currency, additional info when you do traces that are supplied through the Db2 for ZOS trace logic, improved instrumentation for things like Data Studio. So what IBM has said that when they made this huge move to the IIAS and the Db2 for LUW Common SQL Engine, that there was a lot of feature functionality that was not available out of the box. There were some version 5 features which were not included in GA of version 7 when it first came out. IBM is saying today that basically everything that you had in version 5 is now available in version 7 in terms of large-scale feature functionality. There may be some tweaks here and there, but everything that you had in V5 is now available. So before I get into the future or deployments of IDAA, I'm going to first of all, I'm going to see if there are any questions, if anybody wants to raise their hands, and also I'm going to launch another poll. And the poll says, do you plan to upgrade to IDAA version 7 in a certain period of time? I believe it was 6 months, within the next 6 months, before year end.
And of course, Frank, you know, the corollary to this is, have you POC'd this?
I didn't ask the POC question, and I didn't, but the idea is, you know, I wanted to find out where people were in the journey.
Right.
So interestingly, the splits are pretty even. More than half of the folks have said that they plan to upgrade within the next 6 months. Of the remaining folks, half, about a quarter overall, say no, and another quarter say not sure. So there are a lot of people committed to the platform, at least in the next 6 months. So good. Thank you very much for those responses. So we're going to keep rolling. So I want to talk a little bit about the deployment of IDAA. It uses a Docker container. I like to think of Docker, if you're not familiar with it, like VMware without the operating system. The benefit of Docker is that all of the software that needs to be provided is integrated together, is installed together, drops as an image. So I have customers who have been able to upgrade IDAA by downloading and installing a new Docker much more quickly than they could individually in the old days. Let's say integrate Db2 for ZOS and WebSphere and CICS and make sure that they were all at the right levels and all the prerequisites met. All that's done for you. So it actually enables you to be able to keep current, to bring new images down and install them, to exploit new feature functionality much more quickly. Now, it's important to understand that whatever form factor you choose, whether you're using the IIAS or the Accelerator on Z. So let me explain that again because I went into that a little bit earlier. The IIAS is a hardware appliance like the Netezza. Memory, processing capability, storage, all in one box with the software. You wheel it in, you network it up, and you're done. The Accelerator on Z is exactly the same Docker image that you would get on IIAS, except that you run the Accelerator on Z in what is called a Secure Service Container, an SSC, and that runs on processors on System Z, which are called Integrated Facility for Linux, or IFLs. Runs on the IFLs. You're going to use System Z memory, and you're going to use System Z storage, the same way you do for Db2 for ZOS. So there are some pluses and minuses, there are some benefits and some drawbacks to co-locating the Accelerator on Z on the same platform where you're running Db2 for ZOS today. So let's take a little bit deeper dive into what that looks like. But this diagram is showing you that the IDAA on IIAS has three -DB nodes. This is an older slide, but it was a good illustration. -DB is just a different name for Db2 for LUW that we were talking about before. So when I talked about the data partitioning feature, what you're seeing here is a 3-node DPF, data partitioning feature, 3 different partitions that will each store 1/3 of the data on the disk drives that you see down here. There is only a single node when you're using the IDAA on Z, the Accelerator on Z. Why is that? Well, you're really not getting the benefit of separating these processors out because you're using a drawer full of IFLs and you're using a secure service container. So dividing that up into partitions really won't buy you anything. Also, you're using shared System Z storage. So that's why there's a difference in the number of nodes and the way that they're deployed. So some other comparisons between the Accelerator on Z. The Accelerator on Z can be deployed fairly easily. If you have IFLs today, the Integrated Facility for Linux, you download the Docker container into the SSC, the Secure Service Container, and away you go. They're also much more granular in terms of capacity, in that the capacity for an IDAA Accelerator on Z running on your System Z mainframe is how many IFLs you dedicate to it. The more IFLs, the more processing capability you have. It's as simple as that. The IDAA that's running on the IIAS is constrained, of course, by the processors and the memory and the storage that come bundled in that appliance. However, one important thing to understand in comparing the two form factors is that unlike the Netezza, you can field upgrade your IIAS. You can add more memory and you can add more storage. So that gives you the ability to be able to expand the platform that you already bought. It used to be with the Netezza, if you needed more storage capability, you had to buy a new box and move all the data over to it, which was a pain in the ass. So that goes away as a consideration. So here is another comparison, and I like this screen. Again, this is an older slide, but I think that it really tells the story well. The top line is the pure data system for analytics using the Netezza FPGA technology. So if you have a quarter rack, a half rack, or a full rack, that's where the IDAA is today. The IIAS, and this is the M4001. I have another slide for the most current 4002. Third rack would be equivalent to a half rack of the PDA. So if you have a half rack today, all things being equal, you would probably move to the third rack, the M4001. Compared to the Accelerator on Z would be one full drawer of 35 IFLs and 2.5 terabytes of memory in order to get the same storage and processing capability. So this blue line down the middle here is sort of the sweet spot. Now, the important thing to understand about the Accelerator on Z is that that cannot currently span a drawer for IFLs, meaning that you are capped at one full drawer of the Accelerator on Z, which is equivalent to a half rack of what you had with the PDA, with the Netezza. Meaning that if you had a full rack, you would have to have twice as many Accelerator on Zs as you currently have on the Netezza technology. And this is something that IBM has said is going to be removed as a limitation in the future, but it's not today. Right now, today, the capability is that if you want to expand big and to take this to the next level, we can look at the 4002 models. The 4002 models today, you can buy this and drive it off the lot, will expand up to a quad rack. 12.5 terabytes of memory, 324 terabytes of flash storage. All of this is uncompressed, and 600 cores. So just a beast of a processing capability, which is not available today in terms of the Accelerator on Z. Now, if that weren't confusing enough, wait, there's more. What we learned when we were in Columbus teaching our workshop just last month is that the Accelerator on Z can also be delivered on the IDAA deployment on Linux One. Linux One is a box that is comprised of IFL components along with memory, but no storage. I have a link to what Linux One looks like online. They come in two flavors. One is called the Emperor line. The other is a Rockhopper. Both of those are types of penguins, penguin being the symbol for Linux. So you can actually deploy this. I have listed, or actually put the link here, to the Accelerator on Z prereqs for Linux One. So basically now you have three choices for deployment. You have choice number one, the IIAS. I get memory, storage, and processing capability in a box. I wheel into my shop and I network it and I let it go. The second is the Accelerator Z, co-located in a secure service container on System Z, running on IFLs, using System Z memory and System Z storage. And I should actually put up a chart with this. I'm going to do that next time. And then the third is the deployment on Linux One, meaning you'll be using the Linux One processing capabilities, using the IFLs, using the memory, but you'll still need external storage because the Linux One doesn't come with storage. Now, you may say to me, Frank, my head's starting to hurt. It's like too many appetizers on the menu. Which one do I choose? The answer is something that my colleague Kim May has put together, which we're calling the IDAA Buyer's Guide. Now, I don't want to oversell this because we're not going to give you all the answers. We're going to give you a hunting license. We're going to give you a pocket full of breadcrumbs like Hansel and Gretel. So you can understand what some of the considerations are for consuming this technology. It is a spreadsheet. It's available in the handouts. You can download this today. It's the IDAA version 7.1 pricing spreadsheet. And there is a different tab for each different form factor that I just mentioned. There's one for the IIAS. There's one for the Accelerator on Z, co-located with Db2 for ZOS, and a third one for the Docker container running on the Linux One. So it incorporates, for example, if I buy the IIAS, I'm basically done. I get my software, I get my memory, I get my processing capability, I can expand up to a quad rack, so I'm good to go. If I do the Accelerator on Z and it's running it on System Z, I have to buy IFLs. So you have to incorporate the cost of the hardware that you're going to buy and also any additional System Z memory, also any additional System Z storage. If you decide to go with the Linux One model, you're going to have to add in the software and the external storage and the Linux One, which contains the memory and the processing capabilities. So that's what the spreadsheet is intended to do. It gives you, like I say, a hunting license, so you can say, okay, have we added all the costs up? Because we don't want anybody to have sticker shock and say, well, I can just download this accelerator on Z and I'm good to go. But wait a minute, we only have 4 IFLs right now. We're not going to get much work done on that. Well, how much does an IFL cost? Well, Kim has spent a lot of time trying to figure that out, and it's pretty Byzantine as to what they would cost. A lot of these depend on your companies, your enterprises' arrangements with IBM for purchasing hardware and software. So with that, Kim, I'm going to take a pause. If you'd like, I can actually bring your spreadsheet up and let people take a look at it, and you can guide me through, and I can show it to them.
That would be fine, although I do want to make sure everyone understands that this is information that I have gathered. And first of all, I want to tell everybody I'm recovering from bronchitis, so I'm sorry if I sound like I'm barely able to speak, but sorry. What I've been trying to do is figure out how to do an apples to apples comparison if you're looking at pricing, and you're looking at pricing basically based on the capacity of the accelerator, because that really is, at the end of the day, what you're going to be comparing. So what I tried to do, and I also tried to factor in some discounts that are sort of general guideline discounts, and the discounts for most people with ELAs, most customers that have mainframes have some sort of enterprise license agreement, an ELA in place with IBM. These are typically discounted somewhere around, it varies. So I put in a 40% discount. This is an Excel spreadsheet. If you know what your ELA discount is, go in and change it, and you can do this. And basically what I was trying to figure out is what your total cost of ownership is. So the first thing on the spreadsheet here is doing an appliance. So this is like the cost of the appliance with different models. And this is on the first tab of the spreadsheet. And Frank, you are sharing this with everyone, aren't you?
Yes. Are you not seeing it?
No, I can see it. No. I mean after the presentation, so people can play with this.
It's in the handouts right now. They can download it even as we speak if they want.
Excellent. Okay. So anytime you buy anything from IBM, you're going to pay some sort of subscription and support for anything beyond the first year. Anything that you buy that's System Z-based software, it's going to be a separate line item when you buy it. If you buy something distributed, like the appliance version of, like the Sailfish appliance, it's included in the first year pricing. But then you have to calculate, you have to add that for years 2 and 3. And it's typically about 20% of what you pay for year 1. So that's included in the spreadsheet. And there are different models of the IIAS appliance with different quantities of data that you can store. And so the first spreadsheet here that Frank has up just shows the different options, the different models, and basically what I came up with based on a 40% discount off list price from IBM as your what the cost per gigabyte is per month. And so for anybody that's in a chargeback type of environment where you have sub-organizations or customers within your organization that you are selling services to, this can be important. So the first page and the page that's on the screen right now is for the appliance. Frank, can you go to the accelerator on Z? Thank you. I see you going there. So this one's a little more difficult for me to figure out because IFL pricing is really difficult to determine. And for lots of organizations right now, particularly customers that bought new hardware in the past 2 years, IBM had a bunch of IFLs that they just threw in. So you may have IFLs that cost you nothing. And so this is sort of a, do you need to buy IFLs or not buy IFLs? Or are you going to use something that you don't have to pay for because somebody bought it 2 years ago? Here's the spreadsheet. This is how you figure it out. But when you buy, if you're going to do the accelerator on Z, the different components you have to buy the IFLs, and then you also have to buy the IDAA software, which is a Z software component. So you buy that. Here's the pricing. And then for years 2 and 3, you have to calculate that out as at 20%. Again, you would have to sort of integrate this spreadsheet with the first spreadsheet to do all your discounting. But I think this is the basic. If you use this, you can kind of get a sense of what it's going to cost you at the end of the day, so that you can calculate out your monthly per gigabyte cost. And I think that's really what you want to get down to, because you really want to be able to say for this, because when you're using an accelerator, you really want to be looking at the volume of data that you're using it for. And so this is going to enable you to get that really down to something that small, which I think you need to do. So Frank, the next tab is the Linux One tab.
Well, before we leave this one, I wanted to point out to people that the number 3 storage cost is blank, because we have no way of knowing if you use IBM storage or you're using EMC or whatever, but that's going to be an additional cost. The storage is included in the appliance, but it is something that is an add-on, and it's going to be System Z storage. Whatever you're using today is going to have to be added there, and you might have to add memory, because memory is obviously a very important component of the IDAA, and you may have enough memory now and you don't have to buy any, or you might. So we don't have a line down for memory, but be aware of that. That's another variable cost. Okay, so on to Linux One.
Okay, but actually, I'm sorry, go back one more time, sorry. The other thing on the last spreadsheet is there is a limitation on the IFLs. So the most IFLs you can run right now is still 16, isn't it, Frank?
35.
35. Okay, so 35. So you might want to take a look at this too, and you might have to sort of do this backward if you have a lot of data that you're concerned about, because you might want to take a look at how much data you can actually support with 35 IFLs, because it may not be enough. So same deal with the Linux One box. So onto the Linux One. Thank you, Frank. This is basically the same deal. So when you buy these, the Emperor and the Rockhoppers are based on IFLs. And so you need to figure out in the box that you're buying how many IFLs are in there, and then you can back into the number of PVUs. So it's and again, as Frank said, you have to add the storage, and you have to buy the IDAA software, the Z software. So if you're actually interested in doing this, I would be more than happy to work with somebody on this. These are not numbers that IBM wants to give to a business partner like the Fillmore Group, which is why these spreadsheets don't have a whole lot of data in them, other than the IIAS, which I can look up myself. But the other stuff, the hardware, anything that's hardware based, is usually done, it's negotiated on a customer by customer basis. But if you're interested in comparing these, you can certainly ask your IBM rep, and they should certainly be able to tell you so that you can compare, particularly if you're doing Accelerator on Z versus Linux One, because there are some really good deals. My understanding is there's some great deals on Linux One boxes, but I'm not sure that you're going to get enough IFLs in there to really justify running the Linux One as opposed to the IIAS. So that is a totally confusing explanation, but if you're really interested in doing this comparison, and my guess is that you might end up with some really varying pricing, and obviously that's going to, whatever it is you have to take into your manager and cost justify, you want to make sure you understand why you're getting it.
So both a comment and a question for you, Kim. That the comment is, so everyone is aware of this, when IDAA first came out, it came in 2 flavors from an IBM, I'm trying to think of the right word. It's called offering management, but that's an arcane internal IBM term. But it came in 2 flavors, so that since it was a Netezza, which was considered a distributed product, there were a certain group of reps who sold products like Db2 for LUW. And Netezza, standalone Netezza, was sold by the same people who sold Db2 that ran on Linux. On the other hand, there were components of IDAA which ran on System Z. So to make everybody play together well, IBM basically gave everybody credit for IDAA. If you're a System Z rep on account XYZ, if you're the distributed rep on account XYZ, everybody got money. That's not how they're doing it with version 7. The Accelerator on Z is sold by one group of people who only get compensated on Accelerator on Z, and the IIAS is sold by a different group of IBM people who are only compensated on the IIAS. So if any of you have been in this business as long as I have, you remember the RS6000, AS400 battles that used to go on with IBM reps who would each come in and they would talk about their product and disparage the other product, and the customer would end up buying Digital Equipment Corp or HP or something like that because they say this is nuts. So be aware that when you start asking these questions, you might get some funny looks because there are going to be winners and losers when you guys decide which one you're going to buy, and people are going to be in there pitching for what works in their compensation plan. So
Okay.
Go ahead, Kim.
Yes, and so Frank, if you would go back to the Sailfish tab.
Sure.
The other thing that I think is important with this, that is nobody likes to talk about this, but it is the reality. For those of you that own Netezas right now, that own Netezza-based IDAAs, you have been paying the subscription and support on the software component, which was about 75% of the original cost. You've been paying that every year. So if you decide to move to the Sailfish to go to the appliance and you're buying a distributed appliance, you get credit, you get license credit. So if you own right now, and you can look at some of the sizing here for like the M4002-006, you're looking at 10,000 PVUs, which are the price units for that distributed software is sold on. If you already own a Netezza and you currently own 5,000 PVUs, you don't have to buy 10,000 new PVUs. You only have to buy 5,000 to get the M4002-006. And that can be a huge savings. I did one price comparison. I don't know, is that slide in here, Frank? I don't think it is.
No, I don't believe so.
Yeah, anyway, I did a slide on this and I showed in one case, because some of these numbers get gigantic, a new Accelerator on Z was going to cost $6 million. And if somebody did that and did it as a Sailfish instead and traded in their current Netezza entitlements, it was going to cost $3 million. So there could be a potential huge savings there. The only way you're going to find out about that, though, is if you talk to your Netezza/IAS distributed sales rep. So if you're interested in just doing that price comparison, just so you know, particularly anybody that knows how many PVUs they currently own with their current Netezza, let me know, shoot me an email and I will find out who your rep is. And it could just be, an email that says, this is what we own, tell me what it would cost us, or tell me what this is worth in trade-in dollars. Because those trade-ins can be extremely valuable. You would not go out if somebody said, when somebody says you've got System Z software, you've got version 11 and you're moving to version 12, you don't buy all new software. But if you're moving from a Netezza-based IDAA to the Accelerator on Z, you are buying all new.
Excellent, excellent explanation. That's the first time I've understood that, and you've explained it to me before.
I'm not sure I really understand it. And every time I talk to it, I know there are some people, I'm looking at the list of organizations that are on the webinar right now, and I know there's one that understands this, but I don't think many people do understand it, but it can be a huge price consideration.
You bet. So a couple of questions have come up. One is from Donnie Cox. He says, so am I understanding it correctly that if we currently run a half rack, I'm going to bring up my screen again and come back here. If we currently run a half rack on the N3001, it will take us 35 IFLs on Z to be at the same performance level. And the answer is yes. A half rack up here on top is the PDA is equivalent to one drawer of 35 IFLs Accelerator on Z. So the other question I got from Al, which is, so mileage may differ. What flavor are you seeing most directions customers taking? I'm going to put that question to you people. The question is going to be, which form factor are you most likely to deploy in your shop? I'd be curious. The Integrated Analytics System, IIAS appliance, the Accelerator Z Docker running on System Z, or the Accelerator Docker container running on Linux One. And obviously, some of this may be new. This is a gut feel. We're not going to hold you to that. We're not going to come back to you in 6 months and say, you said on August 28th.
Now, Frank, one of the questions, the poll questions that I know you don't have in here, but this is the poll question that I would be most interested in. For those of you who are considering either the accelerator on Z or the accelerator on Linux One, have you spoken to the distributed rep at all, or have you only been speaking to your Z reps? Because I think and this is anecdotal, this is my experience only, is that in 2019, the IBM Z sellers are all over this. And the former Netezza sellers are out focused on the former Netezza customers, and they've totally ignored the IDAA/Netezza customers.
So I'm going to go ahead and close this poll, but the results are interesting. 33%, a third, and we have 69 who've replied, so about 70% of the attendees. 33% IIAS, 56% Accelerator on Z, and 11% on Linux One.
So hey, Lethica, you're not the only one.
Was that a shout out?
Yeah, because they are the first. I think my understanding right now is that there aren't very many doing taking a look at Linux One, but it's becoming. I mean, and Frank, I saw your emails back and forth with the Bobligan people. Obviously, it's a really good option, and it's something people are really beginning to consider.
Yep, very cool. So. Let me see. I have a couple of slides on high availability, and all I want to say right here is that for the IIAS, hopefully all of you are familiar with how reliable the IBM mainframe is. So I'm not going to talk a lot about that, but in terms of high availability for the IIAS, everything is redundant. There are a lot of hardware elements in terms of data fabric, network, storage, processing nodes. On one of the earlier screens, unlike the DPF, I'm going to go back here just because I think it's important. So on the DPF implementation on IIAS, each node has its own storage, but the storage is addressable by each of the other nodes. So let's say you lost one of these nodes at the top, you're not dead in the water. Each of the other nodes can actually run a smaller version of that node within their node. So Node 1 goes down, Node 2 can run a limited version of Node 1 and still access Node 1's data, so you have continuous availability. You're not going to be dead in the water if you lose a node. So all important to understand. With HADR recommendations, high availability and disaster recovery, the idea is that everything you do for System Z, you're going to want to do for IIAS. If you have an IIAS in your primary data center, you're going to want to have one in your secondary data center. If you have Accelerator on Z running in your primary data center, you're going to have enough storage and memory and IFLs in your secondary data center to keep up with that. There's actually a great red paper on HA and DR. I could spend the rest of our time just on this slide. But it tells you at a very specific level, depending on whichever form factor you choose, what the HA and DR considerations are. A lot of it has to do with GDPS, PPRC for metro, and XRC for very wide. So within the same data center, within the same campus, I would use the GDPS, the geographically dispersed parallel sysplex. PPRC peer-to-peer, to be able to replicate data block level at the disk from one campus to the other, and then the XRC to a remote site. So let's say you had a tertiary data center 500 miles away, different grid, different time zone. You can keep all those current. You would just need to have an accelerator in all three, whichever form factor you use. Okay. Flexible deployment options. This is important to understand from a migration standpoint. I can have IIASs living with Z, running in an LPAR on IFLs. I can have a Linux 1. I can mix and match these any way I want at different version levels. I can do this within parallel sysplex. So you can coexist with 5 and 7 at the same time as you're planning to migrate. Workload balancing is important too. This is something that's been available since early in IDAA's life, the ability to have multiple accelerators in the same data center with the same data and be able to route queries to those based on how hot one was. There is something called a capacity weight, which is broadcast back to Db2 for ZOS. So when it needs to run route a query to an accelerator, it can do that based on the availability, as long as tables 1, 2, and 3 that you see here are all on both accelerators. But this is another advantage of the IDAA design, in that, again, you don't have a single point of failure, and you can do workload balancing pretty much the same way that you can do with WebSphere applications accessing parallel sysplex Db2 for ZOS data sharing in a clustered environment. So just checking the time here for a second. I want to make sure we have about 15 minutes. I'm going to try to get to all of this as quickly as I can. Coexistence and migration, data movement and benchmarking, connectivity, and expansion. So let's talk about V5 for a second. I ask everybody who is considering upgrading, why are you going to do that? IBM has not announced an end of service for IDAA version 5 yet, but you can read the tea leaves. So right now today, you cannot buy a Netezza from IBM. IBM is not selling Netezza boxes anymore because the equipment doesn't exist. The disk drives are all gone. There are no quarter rack, half rack, full rack Netezzas left. V5 is gone. You can't run V5 on the IIAS, so you have to move to version 7. IDAA has an enhanced lifecycle policy, which means that this product has a minimum 5 full years of standard support when it was first announced. So when was it first announced? It was first announced in October 17, 2014. So that means 5 years would be, oh, wait a minute, October of 2019. That's not to say that the plug is going to get pulled on support in 2019, but the 5 full year guarantee is going to be up. The PD end of marketing was in April 10th, 2018. Again, there's no end of service, but I would plan prudently. If you have IDAA version 5 in production today, you should be off version 5 on version 7 within the next 12 months, by this time next year. The other thing to keep in mind, not to go all scary on you, but Db2 version 11, Db2 for ZOS version 11, end of service is September 30th, 2020. So if you're planning an upgrade and you're at version 11 and IDAA version 5, you have a lot of work to do between now and the third quarter of next year. Okay, so what do I do to migrate this? Again, there are a lot of great presentations out there with a lot of specifics, but I wanted to give you a high level. If I have a non-accelerated Db2 table, no action required. If I have an accelerator shadow table, the answer is reload. You have to move the data from Db2 for ZOS to the IDAA version 7, but you probably do that anyhow, and you can do that in a coexistence environment. So you still run your queries against V5, with the data that's out there today while you're loading your terabyte size tables into V7. If I have archived tables or partitions, the HPSS, the high performance storage saver, I can restore from a Db2 image copy. Remember, when I have archived the data on the IDAA, it deleted the partitions that were being archived from Db2 for z/OS, but in order to do that, it had to take an image copy. I can take those same image copies and reload that back into the IDAA version 7. If I have an accelerator-only table, and the only place it exists is in IDAA version 5, I'm going to have to recreate that somehow. The Db2 Analytics Accelerator Loader is going to help with a lot of those scenarios. For example, the loader, which IBM OEMs from Rocket, can load multiple accelerators from the same source at the same time. And that may be a key component that you would want to consider if you have dozens or hundreds of terabytes of data in the accelerators today. So just here's an example of the loader, but the high availability load, single load operation, 3 accelerators getting loaded at the same time. Reduced elapsed time, reduced CPU, simplified operations. I'm going to go over the HPSS very quickly. If you have it today, you understand how it works. I can have, let's say I have 5 years worth of data that I want to retain, but for a variety of reasons, I only want to have in my transaction processing database the most current year's worth of data. I partition my data by date. So as I hit August of 2019, which we're in right now, when this month completes, this will be a month, August of 2018, that I could archive to the database because I will have my 12 months online. I can put that August 2018 in IDAA. It no longer needs to reside in Db2 for z/OS. So the HPSS is a great way to segregate data, to reduce the amount of data that Db2 for z/OS is processing, improve your reorgs, your backup, your recovery, etc., because a much smaller data footprint, but still have all the data for the analytic queries that you want to run on the IDAA be able to segregate the data there. I'm not going to go into the details for HPSS. Again, these are from prior slides. The accelerator tables, accelerator-only tables that I mentioned before, there are 4 types of tables. Table 1 that resides in Db2 for z/OS only. The accelerator shadow table, the full table resides in both the IDAA and in Db2 for z/OS. The accelerator archive table, the HPSS that I've just talked about, some partitions may reside in Db2 for z/OS. All partitions reside in IDAA. And the accelerator only table, there is just a thumb that is maintained in Db2 for z/OS. There's no data. All of the data resides only in the IDAA for things like ETL processes. And here's just an example of why I would use an AOT. One important thing that I want to discuss before we close up shop today, the incremental update that we're using today, that's what we see at the bottom of this slide. It's the log-based capture of changes that move from Db2 for z/OS logs, get copied and scattered in bulk over to IDAA. This is the way that updates have been done ever since IDAA came out and the incremental update feature was announced. It is based on InfoSphere change data capture, and it is eventually going to go away in favor of something. It still exists today and it's still supported, but the new feature, and this is just a diagram of ICDC. Incremental update, however, the integrated synchronization, which is going to take the place of the incremental update, is using a Db2 only proprietary means of replicating the data from source to target. So you don't have all the overhead or complexity of ICDC. That was the second biggest complaints after the disk drives and the Netezza that I heard from customers. Incremental update was a pain in the ass. It failed. They had problems keeping the synchronization up, etc. all that goes away. The software for implementing integrated synchronization is available within the Db2 stream. It's not a separate product ID. It's not a separate maintenance stream, so you don't have to worry about something else to update now. It's all going to be consolidated. From a functional standpoint, and I have a couple of slides in here with all the details, but the second most important thing to understand is what I call the elephant in the snake problem that we have always had with any IBM replication technology. And that is that when the replication was occurring, that the source of the replication, whether you're using QRep or ICDC, would always wait to see a commit of the data before it sent it down the wire. So if I run a batch job that updates 1 billion rows and doesn't have any commits until the very end, all of those are going to queue up in memory on the source. Then ICDC sees the commit and he ships them all down at once to the target, and all those have to be reapplied, so that you may be behind your database and the IDAA for as long as it took to apply all those changes. So if I have a batch job that runs for an hour, I may be an hour behind in terms of updating my IDAA because it had to wait for that commit. All of that goes away because the way that integrated synchronization works is, as it sees the change occur, it sends it down the pipe and applies it. The data is not visible until a commit is passed from source to target. When the commit occurs, then the data will be visible. If a commit doesn't occur and a rollback appears in the log, the rollback will be sent down the pipe and all of the changes will be rolled back to the beginning of the logical unit of work. What that means from a practical standpoint, no more elephant in the snake problem, and that your source and target, your Db2 for ZOS and your IDAA, are going to be almost near real time in sync, which will now also aid the HTAP that we talked about before, because now I don't have to worry about changes occurring that take a long time to update. Those will all be near real time. So huge number of benefits for integrated synchronization, and that is available now in preview, and I think in the next code drop will actually become part of the base product. So if you have not ordered code and you get the most current version, 7.1.9, I believe, when you go to implement IDAA, you're going to get integrated synchronization, which is going to be a huge boon. So a couple of slides on this. You'll be able to read these in terms of details, but I did want to show you the differences in performance. Right down here in the bottom, HTAP with CDC versus integrated synchronization. The average wait time to run the queries in the lab test went from 51 seconds to 6 seconds across a total of 89 queries. The only thing that's changing here in the two environments is whether we're using CDC or integrated synchronization. The average latency of the workload dropped from 50 seconds to 3 seconds. So orders of magnitude improvement in latency. Your data, your time to data just got way shorter. Okay, so I am just about to wrap up. I think I have one more poll, and I'm going to run that bad boy right now, which is, which of the new or returning features do you find most compelling reasons for moving to IDAA version 7? And you can choose more than one. High performance storage saver, integrated synchronization, or HTAP. So giving folks an opportunity to select right now, but it looks like integrated synchronization. I really sold it, which is good because I think it's a great feature. That is at 88%, HTAP at 63%, and HPSS hovering just around 40%. So with that, I want to give you one more opportunity to ask some questions. I'm going to close this off. I'm going to close the poll off. If you raise your hands and you have any questions, you can either put them in the chat or I'll take you off mute. Obviously, you have our email addresses. I have contact information here. I have some resources. I have release notes for each of the versions of IDAA, prerequisites and maintenance, the Knowledge Center, our website. So I'm going to take, let me see, I have one here. Okay. Sita Kantra, you have to take yourself off. You're self-muted right now. If you take yourself off mute, go ahead and ask your question. There you go. Go ahead, fire away. I'm not hearing you if you're speaking right now. It looks like you're off mute. If you can't say your question right now, go ahead and put it in the chat, and I'll try to answer it that way. We may have an audio issue. And let me see while I'm doing that if I have any others. Okay, I do see a couple of questions here. Let me see if I can get to these as quickly as I can before we close out. Let me see. So we need to restore Db2 parts from HPSS version 5 and then archive the same parts to no, you don't have to restore them. That was the point of my my discussing the image copy. When you created partitions that had been archived in HPSS version 5, there was a, let me see if I can bring it up for you really quickly. Let me see. When you're using HPSS, and I didn't go over this in detail, where are we? There we go. There it is. Okay. When you archive in version 5, the partitions that are only going to exist in IDAA are going to be sent to image copies. You can see part N-2 all the way down to part 2 and part 1, the oldest partitions, so that they're going to be deleted from Db2 for ZOS. You have a collection of image copies down here which are required to do the archiving. You can restore those from those image copies directly to IDAA version 7. You will not have to restore them to IDAA version 5 first. Okay, so I think I got that question. I don't see any other questions or chats. So I'm going to go ahead and wrap it up. Thank you all very much. There's a short survey as you depart the webinar. Thank you very much for joining us today. I really appreciate the questions and the interest and your response to the polls. Kim, is there anything you'd like to add?
I think the only thing I'd like to add is please contact us if you have any questions. If there's anything we missed or anything that you're kind of curious about, let us know. We'd be happy to help.
You bet. Have a good day, everyone.